This is the question from 2018 physics question paper, and the topic is quantum mechanics. The question is in question number 8. Among electric field E, magnetic field B, angular momentum L and vector potential A, which is or are under odd under parity space inversion operation, and the four options are E only, E and A only, E and B only, E and L only. To know the answer of this question, we have to know what is parity inversion. It is written in that question that parity means space inversion. So if one have an operator like A, which is a function of R, then after operating P on it, then it will come as A, which is function of minus R. This is the main thing for parity. In parity, our R space will be inversed, R will become as minus R. So now in that question there are three variables given. One is electric field, magnetic field, four electric field, magnetic field, angular momentum and A. So let me write here electric field, magnetic field, angular momentum and A, vector potential, magnetic vector potential. Among these four, which are odd under parity, we have to tell that. So for telling that one, we have to write some expressions for E in terms of R. So by Maxwell's equation, we can also write E equals to minus del V del R. It is not exactly Maxwell's equation. We can have a very simple electrodynamics expression, and after that we can have this expression that E equals to minus del V del R, where V is the potential and R is the distance or space. Now if I apply P on E, then as we told that R will go as minus R, and as V is a scalar form, so V under parity V will become as a V only. So if I write a parity, if I operate parity on electric field, then it will be like minus del of PV del of PR. So if I write this one, then del of V del of minus R. So we can see here that the answer is del V del R. So the del V del R answer means it is giving P under P on E is giving minus E. That means it is odd under parity. The parity value is negative, minus 1. So that's why electric field is odd under parity. Now coming to angular momentum. Angular momentum is axial vector, and in axial vector I can write angular momentum as R cross P. So here for that case we can see when we are applying P on L, then P on R cross P on P, angular linear momentum. So P of R is giving minus R, and P of P is giving what? P is a vector, and P can also be written as mv. So it is like m dx dt, or in our notation it is dr dt. So if I apply parity on P, then it will be m ddt of minus R, that means minus P. So in parity on linear momentum, it will give a minus P. So if I write here minus R and minus P will give us R cross P again, and it is nothing but L again. So the linear angular momentum has a odd parity, even parity, because it has a plus 1 value after operating P on L. Now coming to the next one. The next one was magnetic vector potential, which is A. So from the Maxwell equation I can write like that: E equals to minus grad V, del V del R minus del A del T. Now we can see here E can be written as proportional to minus del A del T. From parity conversion, we already knew that minus del T and then P of E A. So P of E is minus E, and now if I write here del T, T is obviously does not change under parity, so we are going to calculate as P of A. So by this expression we need to know that what is the value of P of A. P of A should be minus A, so that we can have minus E expression which is given in left hand side. So vector potential, which is A vector, under parity it is given a odd parity, that means minus A vector will come out. Now coming to magnetic field. Magnetic field we can write like curl of A. So curl is nothing but as a function of R. So if we are going to operate parity on B, then it will be minus del cross minus A. Then it will again as curl of A, which is nothing but B vector. So magnetic field is even under parity. As a conclusion, I can tell among E, B, L, A, E is odd under parity, B is even under parity, L is even under parity, A is odd under parity. So the answer of this question will be E and A. Now coming to the question again, we can see here the option is B. I have mentioned in that PPT which variables have even parity and which variable have odd parity. You can see here time, mass, energy, charge density, power, electric potential, electric density, angular momentum, magnetic field, auxiliary magnetic field, magnetization, Maxwell stress tensor, all are even under parity. Now coming to odd under parity. Helicity, magnetic flux, position, velocity, acceleration, linear momentum, mass flow, force, current density, electric field, electric displacement vector, polarization, electromagnetic vector potential, Poynting vector, these all are odd under parity. Now here you can see E is there, that electric field is there, electromagnetic vector potential is also there, that means E and A are both odd under parity. And also you can see here angular momentum and B is there, which are even under parity. Now here also I have mentioned some of the variables which is changing under parity in such a way that electric field is changing as minus E, magnetic field is changing under parity is plus B, del as minus del, A as minus A, V as V. So by seeing these expressions as well as this table, we can definitely tell that the correct answer of that question will be E and A only.